Okay, this video is going to take a look at solving radical equations. So in the past, you've learned how to solve equations that have no radicals in them, and we have a step-by-step approach to things like that. And now when we start adding radicals in, we're going to have to consider some of the restrictions and some of the, we'll call them advanced techniques to being able to find out the value of x. So, the first thing is to think about some of the restrictions. So, square root and nth root expressions can have some restrictions, and not only expressions, we are also going to deal with equations as well, can have some restrictions. And again, a little bit easiest to see through some examples. So, we're solving, which means we want a final answer that has some x's in it, and let's say we've got something like the square root of x plus 5 just has to be equal to 6. Well, the restrictions that are on this really have to deal with this part of the graph, because we know that we're not allowed to take a square root of a negative number. That's going to require us to have some special conditions on the radicand part, the part inside the radical. That part can't not be negative, which means it must be bigger than or equal to 0. And in the past, we've learned how to deal with inequalities, but here's a little reminder. We solve them as though this was an equal sign, so I just subtract 5 on both sides, and x has to be bigger than or equal to negative 5. And on a number line, what that looks like is here's 0, and here's negative 5, so it could be equal to negative 5, and anywhere bigger than. So this piece right here is our restriction. And we need to, at some point, think about restrictions as we work through the solving of these equations. So let me do the solving in green. So there's kind of two steps. There's a step to do the restrictions, and there's another step. And it doesn't really matter the order. I'll put a number 2 up here. There's another step, which is the solving part. And the solving part, it's not too difficult to do. It's simply isolating the radical, so it has its own steps, and the first part is to isolate the radical, which we've done. Isolate means get it onto one side of the equal sign, so it's already set up that way. Step 2 is to square both sides. So in this case, when I square this side, this will just turn into x plus 5, because a number times itself will just be the radicand part. And I also have to square this side, because whatever I do in an equation to one side, I have to do to the other side. And then after I've squared both sides, I simply solve this equation. And so I subtract 5 on both sides, and I get 31 as an answer. And the last thing that I have to do is check the solution. And sometimes you'll get more than one, so I'll put solutions against the restrictions. And there's a couple ways to do that. One way, and restrictions, there could be more than one. So one way is to just see if 31 is bigger than or equal to negative 5, which it is, and so 31 is going to work in this case. Another way, which I find a little easier, is to just substitute 31 back into our original question. So 31 plus 5 is 36, and the square root of 36 is 6. So you can check it against the restrictions, or you can plug it back into the original equation. And again, I find plugging it back into the original equation a little easier. Let's just take a look at the restrictions in a little more detail before we go fully through and solve a few more of these. So here's our example. We want to find the restrictions on this expression. And notice there's no equals sign, so it's not an equation. I'm not solving for x. I simply have an expression that has some radicals and some algebra, and I want to know what values of x I am allowed to have. So again, inside the square root has to be a positive number. So this x plus 3 has to be positive. And inside this square root, this x minus 5 has to be positive. Actually, let me use a different color for the second one, because that'll help when I graph it. So in this case, I find my x values by just subtracting 3. So x has to be bigger than or equal to negative 3. So if I have a number line and I have 0, somewhere down here is negative 3, and the red values say I could be equal to negative 3, or I can be anywhere bigger. And then the green restriction is add 5 and add 5. X has to be bigger than 5. So 5 is somewhere over here, and here's 5, and these values are bigger than 5. So a number like negative 4, that's going to be right out, because it's not bigger than negative 3, and it's definitely not bigger than 5. Let's take a look at 0. So 0 is bigger than 3, but 0 is not bigger than 5, so 0 won't work. If you put 0 in here, you'd have square root of negative 5, and you're not allowed to take square roots of negative numbers, so we'd be stuck. At 5 and on, when I plug the numbers in, I can take the square roots. They might not work out nicely, but they work out nice enough that they actually have value. So at 5 and higher, I have the ability to have solutions. So sometimes you'll get multiple restrictions, and you have to think about those restrictions together. And the easiest way to think about them together is to draw a picture, draw a number line, and come up with a single restriction. So in this case, the single restriction is x has to be bigger than or equal to 5. It's not good enough that it's just bigger than or equal to negative 3, because those numbers that you substitute in, like 0, don't work in the second radicand. They don't work in this part. So let's take a look at another example, and we'll find the restrictions on an expression. Equation. So let's find the restrictions when we have an equal sign. And so inside the first square root is 3 minus x, and the second square root is x plus 4, and it's equal to 2. Well, you know what? It really doesn't matter that it's equal to 2. What I want to know is still what sorts of numbers am I allowed to put in here, and what is not allowed. So again, and I'll color code this part here, inside here, has to be bigger than or equal to 0, and inside here has to be bigger than or equal to 0, and I solve them. The green one's actually pretty easy to solve. X has to be bigger than or equal to negative 4, so when I draw a number line, here's 0, and over here is negative 4, and I'm dealing with numbers bigger than negative 4. For this one, it's a little bit trickier to solve. I subtract 3 on both sides, and so I get minus x is greater than or equal to minus 3, but then I have to divide by negative x. And so I divide this side by negative 1, and I get x, and I divide this side by negative 1, and I get 3. But, and hopefully you remember this from a past grade, whenever you multiply or divide an inequality by a negative, you must change the sign to the other direction. So instead of x is greater than or equal to, it's going to be less than or equal to. So I have the value of 3, it can be equal to, but it must be less than or equal to. And now what you see is you have a zone in here of solutions. So a solution like negative 5 won't work because negative 5 isn't bigger than negative 4. And a solution like 4 won't work because 4 isn't less than 3. But the numbers that are in between negative 4 and 3, those all work. So our restriction, and this is a little bit tough, is x has to be bigger than or equal to negative 4, and at the same time less than or equal to 3. There is our restriction on this. So you're allowed to pick any number between and including those endpoints here and here. Anything in between is good. Outside here, not so good. Okay, let's go back and see if we can solve one now that we've looked into these restrictions a little bit more. Let's try 2x plus x squared plus 3 equals 0. So we'll take a look at the restriction. X squared plus 3 would have to be bigger than or equal to 0. And this actually isn't a restriction. This is a really interesting one because whatever number I put in for x squared, if I put in 0 and I square it, I get 0 plus 3, that's bigger than 0. If I put in a positive number like 10 squared is 100 plus 3, that's bigger than 0. If I put in a negative 10 times negative 10 is positive 100 plus 3. Any number that I put in here is bigger than, the resulting of squaring it is bigger than or equal to 0, and 0 plus 3 will always be bigger than 0. So this actually isn't really a restriction in this case. So that's kind of nice. It's maybe hard to see, but that's kind of nice. But let's go back and solve this. First step, we need to get the radical part by itself. So I'll just leave it on the left-hand side, and I'll move the 2x to the other side by subtracting 2x on each side. And so I get minus 2x. So that's the first step, isolate the radical. Second step is to take the sides and square them. So on the left-hand side, squaring and square rooting just gives me x squared plus 3. And on this side, squaring it, so negative 2x times negative 2x gives me 4x squared. And now I try and go and solve this. And so I subtract an x squared on each side. So I get 3x squared. I divide both sides by 3 to get the x's by themselves, so I get 1. And then I take a square root. So when I take a square root and it's an even, I get plus or minus. And so now I have solutions. And I just need to make sure these are actually the solutions. So I did step 1, which is isolate the radical. I did step 2, which was to square both sides. I solved, and now I need to check. And there's a couple ways. You could check with the restrictions, in which case, yay, there weren't any restrictions. The other option is put the numbers back into the original equation. So if you test 1, you get 2 times 1 plus the square root of 1 squared plus 3. So that's 2 plus square root of 4, which is 2 plus 2, which is 4. Uh-oh, plus 1 doesn't work. So although taking restrictions into account, in which case there seemed to be none, usually works, it doesn't always work. So we do need to test solutions. And on quizzes and tests, it's really nice for the marker to see the testing that you're doing, the checking that you're doing. So if I test negative 1, I get 2 times negative 1 plus the square root of negative 1 squared plus 3. So that's negative 2 plus negative 1 squared is 1 plus 3. So negative 2 plus the square root of 4, which is negative 2 plus 2. And negative 2 plus 2 is equal to 0. Yay, that's what I wanted. It equal to 0. So although I may think this is the solution, after testing I find out that only x equals to negative 1 is the actual solution. And you do need to go through these steps when you're solving. You need to make sure that you are looking for restrictions and testing points as you go through. Let's do one last one.